Okay, good morning everyone. Now something completely different, as Monty Python was telling. It's very nice to hear about business to customer kind of cases and the life what's there in the business to customers, and the not so nice and a little bit more harsh or dull is talking about business to business. So I'm talking to business to you. However, when you're looking at those trends that are affecting the normal customers, there's a similarity also for the megatrends that are affecting the businesses. And I think I will show you something about that. I will talk about the university cooperation and in a way that why it's important and what are kind of, let's say, IP issues are there inside of that, our development and our actions and so on. So the IP is always behind that, and so I will hopefully somehow lighten that up. I will first talk something about Outotec, not just as a company commercialization, but to make you understand that what kind of surroundings, environment we are living in. Then this university cooperation more detailed. And lastly, something about EIT raw materials, because I think that's also one interesting networking type of issue, and it's very much focused now on the European level. So, Outotec in a nutshell. So we are about, actually we are about now 5,000 people. Altogether, there was some reduction, but then we have made some acquisitions, and then we have bought some companies, and we just made that now we are about 5,000. We have been delivering technologies and equipments to up to 80 countries all over the world. So, and our presence is where we have offices or manufacturing type of or sales offices or something, real actions. We have presence in 30 countries, and you can see those dots. They are everywhere. Our sales about 1.4 billion euros last year, and just a remark about the patents. I come later on that we have about 7,000 national patents and applications in the field of raw materials. It's not on the field of ICT, it's on the field of raw materials. So what we are a process technology company. We have been providing leading technologies and services, and our mission is really this, that we are looking for the sustainable use of Earth's natural resources. It's not a buzzword what we are saying that. Our CEO is really passionate about this. He's very keen on it, and he was he's involved in the cleantech of Finland in the board of there, and really trying what we have made a change there. So we used to have an environmental friendly processes. We used to have resource efficient processes, but then when we were looking at, we really saw that those kind of technologies what we are having there, they are not only just environmentally friendly, but they are also economical processes, and as well they are good for social acceptance, because they are clean ones, and in a way that you can have those technologies in the middle of the cities, like in Hamburg. So the sustainability, we have just changed this old way of thinking more out of awe than to the sustainability issue. We are a global leader in the minerals metals processing technologies, and there have been several breakthrough technologies over the decades. So in copper smelting, most of the copper is made using our technology. It's not the same technology. It's like a car that was 50 years ago, a car. It's a little bit different than car is today. It's full of everything, full of digitalization, full of automation, and so on. And so are our this flash melting technology as well. It's totally different. One remark is that we delivered long time ago to Spain one smelter producing 30,000 tons of copper. In the same furnace, with the modification and changes, with the same outer diameter, they are producing now 300,000 tons of copper, so 10 times more of copper in the same furnace. Besides this minerals and metals processing technology, we are also keen on expanding our scope, expanding our capabilities to industrial water treatment, and also the utilization of alternative energy sources and chemical industry. And for example, we have been in Narva also on the oil shale issues and modernization of that plant. And this is where we are. So we are really in the whole, we are looking, starting from the minerals processing from all ore types. We are not in the mining business. Then we are making refining of those metals of all type of ores. And then besides this was this industrial water treatment and energy. We are not just providing that we go to a plant and deliver something and then go out. We try to have this kind of life cycle services. We try to be with the customers already in the beginning when he has this kind of problem with having natural resources. He wants to expand those to ores and to metals. And we are in the process of discussing with the customer at that phase. Then taking test runs, and then trying to find a solution that's really provides the best available techniques for that, and then to be involved in the plant commissioning and operation, and also, if needed, also at the shutdown services. And when the customer needs, let's say, modernized, then we are willing to help all the time. So this kind of life cycle services is very essential of our scope. What we are doing is really with the sustainability thing, is that when the welfare in the global scale is increasing, then there might be, if you don't do anything, the environmental impact might increase, quite naturally. If you don't do anything, you are just doing with the old way. But what we want to have, that we want to have this kind of in our field, we have this kind of sustainable process technologies for minerals, metals, water, and energy in a way that this eco-efficiency makes that even though when let's say, the production increases, the environmental impact decreases. And this has happened, for example, in copper smelters in China. So they have expanded lots of their production in copper, but at the same time, the sulfur dioxide emissions have decreased to 1/10 what they used to be, from the total sulfur dioxide emissions point of view. And this has been because they have changed their old unfriendly technologies to the modern type of environmentally friendly technologies, which helps them to have more production, but at the same time less environmental impact. Coming back to your megatrends, here are our trends that are affecting what we are developing and our scope, what we are aiming for. The cities, urbanization and growing middle class. When that's happening, when people are going to the cities, they need more and more metals. That's cannot be avoided. We are looking for resource efficiency. That was your number 9, I think. So that is really all type of resources, energy resources, water resources, and so on, and material resources. So this must be really this kind of what we are aiming for. Decoupling wealth and ecological footprint was the previous slide what I showed you, that we are really not, even though wealth increases, the ecological footprint would decrease. Driving for social sustainability, digitalization, also there was one megatrend. In our world, it means that we are thinking about system integration. We are not thinking about the single equipments that will need to be digitalized or automated. We think about the whole plant, how that could be most optimal, how we could really utilize the modern tools, their big data, and there as well in the same context to have the better plans. And we are knowing that the macroeconomy is more volatile, so we must try to face that. And these are, we are doing, having technologies, proprietary equipment, systems integration, creation, what I told, and delivery services, and customers is of course our main focus. And really believing on the sustainable use of Earth's natural resources. And what we are really trying to have this with the technologies are the positive impact. So 20% reduction in potential CO2 emissions, 50% reduction in fresh makeup water, and that's the water issue. Environmental goods and services in our orders, they are really evaluated from outside, and they are about 90% are all this kind of environmentally focused goods and services. And also more energy to be generated through our waste to energy solutions. About the innovation. So what we are doing, so our R&D expenditures last year was about 60 million euros. We have patents, we have about 750 patent families, and then about 7,000 national patents or patents applications. In Finland, just when they are filed in Finland, so we had the highest number of patent applications in 2014. Reason is that the Nokia and those big guys, they are patenting it outside Finland. And why we are doing this, I will come back to this, because this is the whole technology scope. When we are having this kind of wide portfolio, we need to have this kind of patented technologies. With also having this kind of strong open innovation culture, we award our employees with technology prizes. And what is this topic today is really cooperate with universities, research institutes, and our customers in R&D issues. So why is university cooperation important? It's part of what we are looking when we are looking at our technology portfolio. Our technology portfolio, meaning all the technologies what we are having there, we have about, I don't know, 270 various kind of technologies. So there are various ways how to manage that. We can have our own R&D when we are trying to develop new type of products, creation there, our own IP and proprietary equipments. But the downside is that it's really long development time. When we are developing, especially in our industry, which is very conservative, or our customers are very conservative, and big miners or big smelters, and the lifetime of the products it's not only 3 months, it's 30 years. So it's to develop processes for those, it really takes time. We could have in licensing, so we really could have immediate access to the technologies, which is a good point, and also have this kind of license fee based on one-time fee, what's coming there. And this is also shortens the development time really a lot. We are doing quite a lot alliance partnering and joint ventures, and this is can be then with our partners, and having this kind of complementing what kind of technologies what we have. But collaboration, that's where the universities really come from. It's collaboration with customers and research institutes and universities. And one issue of there is not only that it's the kind of first stage to deeper collaboration, but it's also securing resources or capabilities. this way we can have access to the university people who maybe want to work with us later on and get to know them much better in the projects what we are carrying out. Of course, we can really have a mergers and acquisitions, so we can really buy some technology, some small company who has a very good idea and don't know how to really utilize that on, let's say, on the global scale. So we could then buy these kind of companies and then in a way have this expand the IP portfolio there and looking for really this kind of spearhead technologies or leading technologies. And sometimes we can have divestments, so we are really try to can sell our technologies or businesses that are not doing well. Last years we haven't had that kind of problem. So the research and development at Outotec, we are not having this kind of one research unit that's situated or research center that's situated somewhere and doing all the research and what has been carried out. It's done partly at the corporate level, but most of all in all business divisions. All business divisions are responsible for their own products and the R&D related to that. They also are responsible for those kind of R&D issues that are close to their business line. So if there's something happening in the world that they think that why they are doing that and why aren't we doing that, they really should have this kind of choice then to how to grab to that issue. R&D is not just fun, it really creates sustainable the value to Outotec and our customers, and really developing new products and technologies and improving the existing metal production technologies. And during all these R&D actions, we of course continuously take care of developing our own competencies. We must have competent people, we must have critical mass there, and we have to have modern research methods to strengthen the position to be one of those top innovative metallurgical research companies. And that's this kind of a bustle, so there really is the need to develop this technology. We must really have this kind of flexibility, a customizing tool when the markets are changed, how to match our current technologies there. R&D is the driver of company growth, source of new IPR, and platform for alliances. And just mentioned this knowledge development in-house know-how sharing transfer tool. And this is for some of our competitors. They don't have that much of own R&D, and this is one thing that we are thinking is important differentiation factor what we have. The R&D what we are carrying out is not an closed R&D, it's not an open R&D, it's what we call semi-open actions, meaning that we try to utilize first of all our own whole resources in the whole company, and to get the ideas from our own people, and to find the topics, how really this kind of issues should be carried out. And then the cooperation with the universities is very fruitful, because there we can, let's say, expand those ideas or get ideas from the universities as well. Unfortunately, in our business, in this metals and minerals industry, the universities don't have that many fresh new kind of ideas like there are in the ICT business, where the people are when you are a consumer, you know what to develop, but when you are in the business, it's not that easy to how to increase the business or how to improve the business. We have a very good contacts with the universities. I will show you our map of university cooperation network. And there's really long traditions. In Finland, we have been lucky. In Finland, we have most of our people are in Finland. We have about those 5,000, we have about 1,600 are in Finland. We have very good funding system with the Finnish Funding Agency for Technology and Innovation. And that has been one kind of engine in quite many actions where we have, and where we have cooperation with universities and other companies. But now it's the new government has decided that there won't be any more TECES funding for for companies, big companies. But they don't understand that all funding what we are getting from TECES is going directly to universities and small and medium-sized enterprises. We don't get from TECES. We don't get ourselves nothing. We just okay. We just stop the university cooperation then. And then, but this discussion has been going on, and it really seems too hard to understand from the public point of view. Very often when we are having this network R&D, the IP issues are very often critical. So there are parties who are generating value, have some new idea. They really think that this idea can generate money in a long term, and lots of money. However, very, very seldom is that the case in our business. So it's mainly the IPs are that kind of source of showing that we are good in this thing, and we can, in a way, protect our technologies there. It's more protection, but to create value, that's in many cases not that easy for those who have very good ideas. However, in many cases, what IP has been done, it can be used to different solutions. So that's when we are expanding our offerings. Some cooperation programs. So I was praising and blaming TECES, or not TECES itself. TECES has done what they have done. So you see that from already 1980s, we have had these kind of 5 years big programs going on, and on the latest ones are those what called SHOCs, these Finnish Metal and Engineering Competence Clusters, or competence cluster programs, and they have been very big ones. There are companies, metal producing companies from Finland. Of course, this is Finnish actions. And then all those major technical universities, as well as research institute, VTT there. And they have, from those has been hundreds of PhD theses coming out of that. It has really expanded the knowledge background, and has made these companies, which are not rivals, to work together. So we are doing this really with the cooperation with professors, academic elite. There are various funding possibilities besides this TECES. There are also national fundings elsewhere in Germany. We are involved also in the European Union programs. But then we have also this kind of a direct funding. We are really funding some professors, let's say in water business, giving money that they would stay there for 5 years at least. We are keeping our topics on university's agenda. So it means that we have to be very active in the university policy. We want to influence there if they, in a way, if they ask our opinion, we really say it. We say that if we are looking from the metallurgy kind of things, we really say that you have to have these kind of education, you have to have this kind of research there, and then try to be active. And as an example, my boss, our CTO, Kari Knutila, he has been there working also as a research professor for University of Oulu, and they have just now they started a new faculty in mining business, and he was very much behind that actions, that how could they combine the various kind of departments in the Oulu University to focus also on the mining side and have a faculty there, and which really serves the northern part of Finland where most of our mines are. This potential future employees through diploma doctoral thesis is very active, especially from those TECES projects. And it really ensures the continuity of education, and our point is really having this regard universities as an integral part of Outotec's R&D. The IP issues are very easy when we are just ordering something directly from the universities, because then we have the IP rights. They are subcontracting us the research work. Then in cooperation programs, there are this kind of where there are many partners. Then there are these IP rules which are quite common in today, and there are this kind of it's quite clear. And then if nobody wants to have those IPs, there also the industry partners have the possibility to acquire that IP. And this shows the network what we have. So many universities, research institutes in Finland, in Australia, New Zealand, in China as well, and then in Canada, USA, South Africa, Germany, quite many, because we have a second biggest part of our offices is in Germany, and also in other Scandinavian countries. And this is not just that we know someone there, but we also have a common projects there, and we want to. We are this kind of. They want to have us quite often with them in the projects. Then some words about European Institute of Innovation and Technology. You maybe see after a while why I am showing this. This EIT is an independent EU body, and that's really trying to have this kind of supporting new ideas through knowledge and innovation communities. And it combines business, higher education, research and technology, and trying to have entrepreneurship kind of issues, new kind of small and medium-sized enterprises, new business coming out of that. And this is it's funded coming from the, let's say, Horizon 2020 money, but which is then centralized or put set to the EIT, and it has then the ability to share this money to those communities. So students to entrepreneur, ideas to products, and from lab scale to customers size. There are three existing old ones. This started in 2008. There are three existing KICs already. They are Climate KIC, ICT Labs, and InnoEnergy. This has been existing. Now this year there are two new ones. It's the Health KIC and Raw Materials KIC. And then they would have, if it goes well, next year they would decide on the manufacturing KIC and food KIC, and maybe then on 2018 urban mobility KIC. The raw materials KIC, which was that one, so it's not just that, okay, now we make this kind of KIC, but it comes after competition. There were several in health. There were 5 if I remember right, 4 or 5 big consortia trying to compete from that one. In raw materials, we had 2 competing consortia there, and this consortia where we are in, it won, and it now has been accepted as an official raw materials gig. It boosts the competitiveness, growth, and attractiveness of the raw materials sector, and focusing on radical innovation and entrepreneurship. So IP issues there again are becoming very important, and really to develop raw materials into major strength for Europe. This is coming from the European Raw Materials Initiative 2008, and then now it's really focusing on the one big action is this raw materials gig. And try to have game-changing businesses, boosting the existing raw materials sector with the new materials in production and processing units, have this system integration there as well, and setting up new partnerships on the whole value chain, and having these ICT solutions, smart product design is all involved in that. And going for education and for new entrepreneurial education, as well as just try to help the graduates, the professionals, and lifetime cycle educations. This is the network, what's there. So we are 116 partners. So this is the world's largest network in raw materials. Coming from 22 countries, and there's a special focus on the East-South Europe. Whole value chain covered, and business parts represent about 700,000 jobs to 200 billion turnover. There are 6 so-called co-location centers. One is northern one, the Baltic Sea, western, eastern, central, and southern. And they are, let's say, they are multinational co-location center. So for example, Baltic Sea, which is located in Otaniemi, has the Finnish universities and partners there, as well as partners from Sweden, and Tallinn University is also one part of that co-location center. The idea is that all these actions, what's happening in the EIT, is happening through these co-location center in a joint cooperations. So they are not specialized in one certain item. So you could say that northern one is more, they have more knowledge in mining, but all the other ones who have knowledge in mining also are able to be part of them projects, or they can be part of the other projects. So this is here you can see those partners in the Baltic Sea. Its main competencies are coming from the materials, tools, and services, equipment and services, and really having this kind of system integration in minerals and metallurgical processing. And here you can see that when you are looking at the whole gig, you have this kind of quite good balance between research organizations, between higher education organizations, and then the business partners. And total budget this is for 7 years, 7 plus 7 years. For the first 7 years, the budget is about 2 billion euros, meaning that from that, about 25% is this kind of money that's granted then to those projects. 75% is so-called gig complementary actions, meaning that the actions what the partners are doing for this certain type of projects. Could be like having this kind of infrastructure in education or similar type of issue. So this is a new one, and really boosting up the network between companies and universities and so on. And this is of course a very natural cooperation network for coming Horizon 2020 calls. Last slide as a summary. So Outotec and innovativeness in R&D. We have a strong market position, we have technology leadership, and we want to have this one and in the further ones. We are one of those leading process solution technology and service providers in the mining and metallurgical industry, and we are knowing the whole value chain from the minerals to metals. Customers partner and really this life cycle of the plant, and success is really based on the extensive research and development and focusing on the sustainable technologies. And of course, customer satisfaction is there, the number one. And really, as the last one, this networking R&D. It really needs, from our side, a proper R&D portfolio and technology portfolio steering, and really this close cooperation with the universities. So, thank you.
Thank you, Morten Øyen, NTNU in Trondheim. I would like to know a little bit about your portfolio with universities. How much of the total contract portfolio is contract research? How much is collaborative research? And is most of the collaborative research based on your background IP?
That was not the easy one. I have to have the numbers right behind me. Let's say we are getting, I can say it the other way around. We are getting direct funding about 2.5 million grants from national and international sources. So all that basically goes to the universities. But then there are lots of actions with different universities where we are, let's say, we are subcontracting some actions to the universities, and they are doing these kind of issues. And of course, we are funding some diploma works and so on. So it changes, it varies every year. And of course, then the IPs are mostly, because normally we have the IPs. And we want to go deeper to some issues. We want them to search to the. We know what happens, but we don't know why it happens. So we let the universities to figure out how to find out what was the physical and chemical reasons for those issues.
So that's incremental research based on your background IP.
That's something, but sometimes it's really this kind of new type of research. So we want to have about 5 to 10%. It would be this kind of exploratory type of research, and then let's say the new product development and incremental are, of course, the major part. But there also to keep this kind of balance, and maybe depending on the financial issues. So then we might have the proportion might change, unfortunately. But this 5 to 10% is really what we are aiming for, and for those, really we want to have utilize the universities to explore what are the reasons there, and could there be some new idea to be developed. And sometimes it really comes from the universities that they want to go further on, that is this possible, and could you change the game with this kind of research?
I definitely have.
Thanks.